they were extremely rude to me, so I had to respond simply as a point of honor, and that's this. So let's begin. I'll start with the only valid criticism you had of me, and that is that I misrepresented your model and didn't research it enough. You're right. I didn't look up almost anything you believe. But now that you've told me so many of the things that you do believe, even better. Let's go through how all of them are wrong. Since I botched your model so horribly, let's go straight to yours. This is the one you showed me to explain the seasons. It attempts to account for the temperature differential throughout the year, but I'm sorry, it's not compatible with observation. Here's why. These are the two tropics. I don't know what you think these circumferences are, but it's safe to say that this one is smaller than this one. If that's the case, one of two things must be true. Option 1. This object maneuvers the inner path in a shorter amount of time than it maneuvers the outer path, which would make summer shorter than winter. It's not. Option 2, it moves much slower up here and much faster down here so that all of the circles take the same amount of time. That would mean the sun moves through the sky at different speeds throughout the year. It doesn't. So sorry, this model doesn't work. Now let's go to the one you showed me for night and day. We all know that precisely half the Earth is experiencing day and the other half is experiencing night at any given time. So your model must reflect that, and this one does, but at the cost of being even remotely reasonable. You've got the sun illuminating half this surface with an arbitrary and rigidly straight line down the middle. How does this work? How does light leave this object and travel one distance to stop here, and travel some totally different distance to stop over here? You guys love to talk about refraction and such things, so please explain how that works. And that's not the only problem. Here, you've got the sun and moon always opposite each other. Well, sometimes we can see the sun and moon at the same time. How does that work? What is an eclipse? When in this model does the moon get under the sun to block it? How do they get on opposite sides of the Earth for a lunar eclipse? If the sun is very, very close and is also the source of all our heat, why doesn't it get hotter when you go up towards it in elevation? None of it works. We've barely even started, but let's review. We are trying to explain just two phenomena, seasons and night and day. To do this, you have two different models, both of which are incompatible with observation, but furthermore, they are incompatible with each other. Why can't you even attempt to explain both of these phenomena at the same time? Going back to your day and night model, it's weird because you said that the sun moves between the tropics. Why isn't that shown here? Because if you did show that, you'd also have to change something about how far the light reaches, which would make this already absurd graphic even more absurd. Then, if we go back to the one for the seasons, why can't you show the dark half and light half while showing this? It's deliberately not shown because it would be obviously inconsistent. Therein lies the problem with the flat Earth model. You don't have one. You can't even explain two phenomena with the same model. The globe model has no problem doing this. This ball spins, so the half facing the sun is day and the other half is night. As it goes around the sun, the hemisphere receiving more direct sunlight experiences summer. The one with less experiences winter. That's right, sorry to burst your bubble, it doesn't correlate with the distance from the sun. Sunlight shining directly on the ground, more energy per square mile, hotter. Sunlight at an angle to the ground, same amount of energy distributed around a greater area, cooler. And there it is. Both the seasons and day and night are explained immaculately and, go figure, simultaneously. Honestly, I could stop right here. If you were to respond to this with anything other than a model that can explain at least those first two observations simultaneously, your viewers should find that very indicative of the fact that you don't have one. But while we're here, let's go through a few dozen more key points. Given that we're on the subject of models, let's hit the one you use for your explanation of the Coriolis effect.
You can kind of draw a clockwise orbit, Bob, in the middle there. And you can see how this would cause, there you go, if the sun and moon are moving in this and, they're diamagnetic and pushing water, causing tides. And then you've also got these winds that and storms that would, have to be what the sun and moon would cause.
Would have to be? How? You haven't explained anything. So the sun pushes water to get the air currents, and the moon pulls water to get the tides? Also, does the sun push the atmosphere in one direction to the right and magically in the other direction to the left? What about storm rotation, which is what this whole thing was about? You've made no attempt to even put the sun and moon in there and physically explain anything. You just say words relating to electromagnetism and hand wave it away.
No, Dave, we're not trying to claim that it's all caused by magnetism. My God, you extrapolate stuff that is just utterly ridiculous. We never said that, and they are electromagnetic phenomenon, like we have been claiming for a long time. Electromagnetic, like we have been claiming for a long time.
And another thing here, guys, even if we grant you this magnetic magic that you're looking for, it's still inconsistent with your model. Here's why.
The line going through the middle of the screen, if you picture the sun traveling from the right side of the screen to the left, it would create those same wind patterns above and below it.
Sorry, didn't you say that the sun moves from tropic to tropic? In that case, the boundary that divides the direction of storm rotation would also move from tropic to tropic. It doesn't. Storm rotation doesn't vary by the time of year. Also, why wouldn't compasses follow the sun through the sky? Also, why wouldn't storms speed up during the day while near the sun and slow down at night when the sun is away? Also, if you're claiming these southern winds are so incredibly fast, how is that possible if they're the furthest away from the source of the effect? None of it makes sense. In actuality, the Coriolis effect is just the result of basic physics relating to rotating bodies. That's why the equator is the dividing line. Pretty simple, don't you think?
Which makes a whole lot more sense than the Coriolis effect, being the reason in the heliocentric on the ball Earth for storms going in opposite sides of the equator. In fact, that is just silly when you think about that. That makes no sense whatsoever. It's ridiculous.
No.
Wow, very convincing counter-argument. Let's move on.
Astronomy and astrophysics and all of that, Dave, these aren't even real sciences. Okay. Now, you obviously are going to claim that they are, but the reason that they're not real sciences is because the only thing that you can do is observe them. You cannot test them. You cannot do anything to be interactive with them. You cannot generate hypotheses or experiments or anything like that. All you can do is simply observe.
Sorry, guys, that's dead wrong. There are hundreds of examples I could choose, but I'll use this one. In the 19th century, we noticed irregularities in the orbit of Uranus. We realized these irregularities could be explained if there was another planet perturbing its orbit by gravitational influence. We did some math and predicted that there should be another planet in a particular place. We looked in that place, and what do you know? There it was. You can't get any more empirical than that. Do some math, make a prediction, the prediction is verified. The discovery of Neptune is a great example that corroborates Newtonian gravitational theory and demonstrates that astronomy is an empirical science, just like any other. It's not surprising that you don't understand this, because this is one of many instances that you demonstrate yourselves to be exemplars of the Dunning-Kruger effect. This is where your absolutely minimal experience has lured you into believing that you have expertise in a particular field, where in reality you are essentially incompetent. It is a cognitive bias that will be demonstrated many more times in this video. Now let's move on to another category. There are about 1,000 flat Earth gotchas that all amount to an inability to understand conservation of momentum. These are your helicopters and planes arguments. Let's see which ones you're guilty of.
Yeah, absolutely. Like if you're doing an Olympic, say, long jump event, I would always opt to jump from east to west because, where you're going to land should be racing towards you.
No. When you jump off the Earth or take off from the Earth, you retain the momentum imparted upon you by the rotation of the Earth. This has nothing to do with the atmosphere. It's also very easy to prove. Stand on the back of a moving truck. Jump up. What happens? Do you fly back off the truck at 30 miles an hour? No. You land right back where you started, even though the truck has moved forward while you were in the air. Why? Because in the air, you retain the forward momentum of the truck. When you jump off the Earth or take off from the Earth, the same thing applies.
And of course, the globe earthers are going to say, well, you have your momentum that's lent to you by the Earth, spinning east, and you're going to retain that momentum forever. And the same thing applies to airline flights.
Yeah, you got it. So, are we good here?
But if you do a test on a train or, like you said, on a plane, and just simply jog from the front of a moving train to the rear and maybe time yourself or just observe, and then do the same thing running or jogging to the front of the moving train. I've done this myself. I promise you that you'll find that it is much easier to run from the front of the train to the rear.
That's your test? Pretty tough to reproduce, don't you think? Here's an idea. What if it was harder to jog to the front